Hey, Calcula's Math Industry, and we are going to take a look at rational functions. So recently, we've been looking at reciprocal functions that look like these. But what we can also take a look at is the rational function. And what if I told you that these two equations are actually equal and equivalent to each other? But how? And what if I told you to find the asymptotes, the x and the y intercepts, it's actually easier to do the standard form or the rational function. But why is it called rational? Well, in a ratio, we tend to compare two numbers, and usually we sometimes find them in fractions. So it makes sense that you have, for this one, a divisor, where something like a polynomial is divided by another polynomial. So to understand how rational functions are a little bit easier to understand, but also give you a little quick hint to get through the mathematics, we're going to have to take a look at this chart. So this chart that I made, the left side is the reciprocal functions that we learned in the last video. The right side takes a look at the standard rational functions. This is the vertical asymptotes, the horizontal asymptotes, and the bottoms are the x and the y intercepts. So, for 8 seconds, pause this video if you want to think. What do you notice? And what do you wonder? Well, what I've noticed right here is when you take a look at the vertical asymptotes, we're going to use different colors to kind of understand. The vertical asymptotes for like the number x equals 4 on the top one is going to match the opposite of the bottom x minus 4. So we can take a look right there and immediately say, hey, the opposite, boom, 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 done. And what about the horizontal asymptote? We're going to put it in this color right here. Well, the horizontal asymptote is going to be the variables where they're divided. So we have 1x divided by 1x, and y is 1. This sounds like cheating, but it's actually not, because it's a genius strategy. But what about the x-intercepts? Well, the x-intercept is going to reflect on the x minus 3. Or if you take a look at the opposite, we have a positive x right here. Wait, wrong color. We're going to change it to green. So we know that there has to be an opposite right there. And we have a positive 3 right there. And finally, the y-intercept is going to be right here. Notice how we have a negative 3 over 4. And then we have a negative 3 over 4 right here. So what the problem literally does to you is, rationally, the rational function literally does the work for you. Ha ha ha! That's really, really funny. And the other part is it also works with here and here. But the question is, math is more than just memorizing. But how do we actually do out the work? Because sometimes your math teacher might be crazy saying, okay, then can you show me your work so you can get full credit? Well, here's what the work actually looks like. So right over here is a completely different problem, but it's a rational function. Because you have a polynomial divided by a polynomial. And because of the color-coded things right there, we'll understand how we got our answers from this all the way to this. So like we said with the vertical asymptote, it has to be the opposite of what we can find. Remember, to find the vertical asymptote, we have to get to an undefined answer. So what x is going to force us to get a divisor of 0? What we have to do is equal this to 0, add 4, add 4. Then we have 2x equals 4, divided by 2, and x equals 2. So if we put 2, but if we put negative 2, x equals negative 2, it will force the equation to be 0. So x equals negative 2. Wait, this has to be a negative 4. There was a miscalculation. So negative 4 divided by 2 is negative 2. So that's how we got an x minus 2, which means getting to that undefined answer will get us to a vertical asymptote. What about the x-intercept? We can color code that in green. So we have to put the numerator set equal to 0. So x minus 5 equals 0. That becomes x equals 5. So we have x equals 5, but in a coordinate form, we're going to have 5, 0. That's where this strange rational function strikes the x-axis. What about the y-intercept? Well, without really any using of a calculator, the y-intercept is going to be the constant on the numerator divided by the constant of the denominator. Well, even though it does seem like we're memorizing from this right over here, sometimes math equations can't really tell the whole thing unless you dive deeper. So we can say 0, negative 5 divided by 4 is a y-intercept. And the horizontal asymptote is going to be the degrees of the coefficients. So we have 1 and 2. So what happens right over here is the horizontal asymptote. 1 divided by 2 is going to be y equals 1/2. And that's what's going to happen. And you can't really do the math with everything, because sometimes it will force you to equal things to 0, but other times it gives it away. If you really want to go crazy, and if you really want to find the x and the y, you got to insert zeros into the x and the y, depending on what you want to do. So that is technically how you show some kind of work, but yeah, that is how we do it in high school. But here's another question. What if we're trying to deal when problems like these arise, where scenario A, the numerator is smaller than the denominator, and scenario B, where the numerator is larger than the power of the denominator? Oh, and talk about that, just to make a clarification, that q was not supposed to be an exponent. It was supposed to represent the q right here, but then we have x divided by x to the power of 1s, and if they were the same, that's how you can get the horizontal asymptote, right here. So there was a clarification. So right over here, what do you do if you have the power of the numerator smaller than the power of the denominator? Well, we know that sum is going to get really, really, really big. So it's going to be a lot larger on a graph. We don't know that until we actually graph it, but we do know that the asymptotes, the ratio, is going to tend to reach towards 0 more than infinity. So it's going to reach towards the 0. On this side, however, when you have a numerator where the leading coefficient exponent is higher than the bottom one, it's going to be infinite. So what happens is the ratio is going to strive to go towards infinity, where there is no leveling off in the graph. But also, the horizontal asymptote, you don't have one. So that's what happens when you have these kind of scenarios. To be rational, it kind of does make sense that the rational function is easier to understand and actually calculate the math. And rationally, that is how we understand rational functions. I hope this video has helped you understand rational functions. Thank you for watching Taoping Airlines Math Industry. like and subscribe.